and gentlemen, this is Mr. Cates doing my first ever web lesson. So, today in class we were looking at max-min problems, and we got through projectiles, and we also did number-based questions, although I'd like to go back and try another example of those. What we did not get to is area and revenue, and I'm going to focus on area for this lesson specifically. We're going to use the same five-step solution for these types of problems. So there should be a let statement, there should be a diagram, you're going to be figuring out an equation, you're going to complete the square to find the vertex, and then finally you're going to have a concluding statement. So let's give it a try. This is actually from your notes from yesterday. So take a look at this. A rectangular field bound on one side by a river is to be enclosed by 1,200 meters of fence. Find the dimensions that will give the maximum area. Well, step number one in this one, I would suggest going with the diagram before we worry about a let statement. So a rectangular field bound on one side by a river is to be enclosed by 1,200 meters of fence. Okay, start off by drawing a river here. Beauty. And next up, the fence has to enclose this river. Side here, side here, side here. Perfect. And now we need to assign some variables. We don't know what these side lengths are, so I'm going to call this side x, this side x, since they're the same side, and then we're going to call the length y. Now I'm in a good position here to do my let statement. I'm going to try to actually type my let statement here, if it'll let me. Let x and y be the dimensions of the fence. Okay, so we got our diagram, and we have our let statement out of the way. Next step is to figure out an equation. Can we think of any equations that relate x and y in this situation? Okay, thinking about it. Well, we do in the question have one clue here. So we know that the fence in total should be 1,200 meters. So that means this, this, and this. I'm not sure whether you guys can actually see that, but the x, the y, and then the y should be 1,200 meters of fencing. So I can actually set that up. So there's two x's plus the one y. And what should that equal? Well, that should equal to 1,200. You're going to see in a moment that it's going to be useful to have y defined by itself, because eventually we want to combine our two equations into one equation. So I'm going to get a rearranged version of this equation, get y all by itself. So I'm going to bring the 2x over to the other side, and now it's a positive 2x. We do the opposite operation. So we're bringing the 2x over to the other side, so we're subtracting 2x. Okay, next up, we got to think of a second equation. A second equation relating x and y. Well, that clue is also in our question. Find the dimensions that will give maximum area. So that's what I'm actually looking for. I'm looking for the dimensions that would give maximum area. Well, we do know the formula for area of a rectangle. So this is a rectangle right here. We can fill that in. The area is the black part right there. And the area, black part I just filled in, is equal to x times y. Makes sense? Length times width is the area of a rectangle. In this case, x and y are dimensions here, so area is equal to xy. Now, if we want to maximize area, first of all, I can't solve this with these two variables in place. I need to have an equation that only has area as a variable and either x or y. So what I'm going to do then is I'm going to substitute this rearranged version right here in for y. X times 1,200 minus 2x. Okay, we're going to expand that out. We get 1,200x minus 2x squared. Let's rearrange this so it looks a little more familiar. Minus 2x squared. All I'm doing is just moving the two terms, keeping their signs the same. Now this should look like something that I could possibly complete the square on. Because if you remember, we're looking to find maximum area. And when we're talking about maximizing different values, we're usually talking about finding a vertex. So we want to actually maximize the area. Imagine that our area is kind of like our y value in this situation. We're trying to maximize that. So we're going to try to complete the square. So to complete the square, our first step I taught you guys for completing the square is factoring out the a value, so the negative 2. What's left over? We have x squared and negative 600x. Step number 2, we need to figure out what the c value that we're adding and subtracting to this is. X squared minus 600. And that c value is found by taking our b value divided by 2 to the exponent 2. In this case, we're talking about negative 600 divided by 2 squared, which is negative 300. Negative 300 squared is 90,000. So we're going to add that 90,000. And then we're going to subtract that 90,000. Okay, let's get a little more room to work with here. Now we've got this part right here that is actually going to turn into a perfect square. To figure out what that perfect square is, we take the b value and we divide it by 2. So the b value here is our 600x. And so negative 600 divided by 2 is negative 300. Square this. Now that takes care of all the stuff I've underlined in green here. And then we're going to take this negative 9,000 out of the brackets, which means I need to multiply that by negative 2. So negative 90,000 times negative 2 is positive 180,000. Okay, so that is the square completed. We know what our vertex is. And now we got to think a little bit of what our answer is. So in this case, if we imagined that this was essentially the relationship that we drew here. The relationship looks something like this. And this was our area. Remember, that was in the place of the y value here. This was our x value. So it's asking us in the question here to find the dimensions that will give the maximum area. First, I'm going to look for the x value that's going to give me maximum dimensions. So basically, this x value right here that happens, where's the vertex here? And that value is positive 300. And then to find our y value, we can take a look at this back at one of our earlier equations here, and sub x into that equation. And we can find that y is equal to let's refer back up here, 1200 minus 2x minus 2, and we know that x is actually 300 where this takes on a maximum, so we're going to substitute that 300 in. Y is equal to 2 times 300 is 600. 1200 minus 600, we have 600. And so we have solved what the question is asking for. Find the dimensions that will give the maximum area. Those dimensions are 300 and 600. We're going to end with the therefore statement. Therefore, 600 meters by 300 meters are the dimensions that will maximize the area.